Alright guys, so in this lecture we're going to cover matrix multiplication. This is making up lecture 2 in your notes. I couldn't lecture because I was having COVID. So I'm going to try to be as straightforward, as streamlined as possible. I know you're going to be watching it over the weekend, so I don't want to take much of your time. Alright, so matrix multiplication, it's going to be a little bit weird. And the reason we do it that way is because it's going to work well with composition of functions. In fact, that's the only reason to define it the way we will. And it's going to be a little complicated, a little convoluted, but once you get used to it, you'll be very comfortable multiplying. Moreover, once you understand the concept or the reason why we do it, then you'll be comfortable with the idea as well. At first, it'll just seem like we're trying to torture you. And it's mathematics. No, I'm kidding. It happens sometimes that we have to introduce things that are not the most straightforward. Anyway, so let's say that you have a matrix and it's written in terms of its rows. So in this case, A1 would be a vector. So let me remove that box there. And that would be just the vector, row vector, with the first row, A11, A12, all the way out to A1n. So that would be your first row. Then A2 would be your second row, and so forth and so on. You can do the same with the columns. You can write it the matrix B is an n by k. Then you have n rows and k columns, and then you're going to have your k column vectors. And here I had written it here, you see. And you would have right there your column vector, so just collecting them. So it's going to be useful for us to write the matrix multiplication compactly in a formula. However, I must tell you that the formula will look way more complicated than needs to be. So we're going to start then working with examples to try to explain how things work, and we're going to try to use colors to motivate it. All right, so I had a really ugly color because I changed this to the colors in Acrobat, so it would be more pleasing if you're watching it at night on your phone, so it wouldn't be white with black font. But this box was horrible, so I had to change things around. So it's already saw my notations, but let me repeat what I said. So if we have matrix A and B, A is going to be of size m by n, and B is going to be of size n by k. So you see the n's have to match. That's why I connected them here. If they don't match, just as with addition, whenever the sizes of the matrix didn't match, we just couldn't add them. With multiplication, the middle ones have to match. The ones outside are free. And what they're going to give you, the ones outside, is the size of the remaining, or the product. So if the n's match, then the product for this, or the size of the product for these two matrices, is going to be m by k. So the outsides will give you the size of the resulting matrix. And the matrix itself will be given by C, which is going to be A times B, and the ijth entry of A times B, which I'm going to call Cij, is going to be the transpose of the vector AI dot product Bj. So remember, last time we did the dot product, this is why we introduced the dot product. So I could define each entry of the multiplication of the two matrices. So let's take a look at an example, because this definition, even though it's very elegant, it's not very useful. Let's be honest about it, because it's kind of hard to follow. So let's go ahead and do a few examples, and hopefully this all makes a lot of sense. Okay, so we're going to look at, firstly, let's grab this column, or this row rather, column, he said. A1, that's following the notation that we had in our formula. And let's call this other one I changed them up. And this is going to be B1. So as it's writing them, it keeps the colors, and then I don't know what it's doing. So now the matrix C, the first entry is going to be C11. Now to get C11, what I do is I grab this first A11 and I make it a vector, a column vector. That's what this transpose is telling me, that I have the row vector and I'm going to turn it into a column. So C11 is going to be the column 1, -3. Oh my goodness. There. Dot 0, -2. Now we know how to do the dot product, so we do 0 times 1 is 0, plus -3 times -2 is +6. So my first entry is going to be 6. Now let's go to C. By the way, the matrix C we said was going to be of size. This one, that's right, is 3 by 2. This one is 2 by, I should have started with that, 2 by 3. So my resulting matrix, remember that is going to be of size 3 by 3 because it's going to give me the outside, gives me the first, the number of rows, if you will. And my second one is going to give me my number of columns, or the number of columns. So the second gives me the number of columns of the resulting matrix. So I know that the matrix will be 3 by 3. The product C is going to be 3 by 3. So I'm going to have that is going to be, I have to do C1, 1, C1, 2, C1, 3, C2, 1, C2, 2, C2, 3, C3, 1, C3, 2, C3, 3. So of course, we're going to start then getting some tricks, because if we have to write each one of them, that's going to get annoying. But let's do a few of them so we get comfortable. So C1, 2, you're going to have A1. Remember, the I matches the I. An I for an I, you could say. So the 1 is going to be an A1 transpose. So I'm still using A1. But now I need the J is given by B. So I need B2, and B2 is this guy here. So I'm going to move over, and I'm going to leave my A1 alone. And I move over, and I get 1, 0. Let's do that product a bit quickly. 1 times 1, 1. 0 times 3, 0. So 1 plus 0 is 1. So we're going to put a 1 in the 1, 2 position, so moving over. Now, if I want the 1, 3 position, I'm going to have to move again to B3. So let me scroll a little. I don't know why I'm writing kind of in the corner. I feel like I'm writing on the box for on a matchbox or something. So C1, 3. I'm going to keep A1, 1, -3. And then you're going to move to 2, 2. Dot product. By the way, in the previous one, I didn't put the dot. I didn't put the dot here. It's a dot product. So there. So 2 times 1, 2, minus 6, which is 2 times 3. And that's going to be -4 for the next entry. And then you now need the second row. But for the second row, you're going to start with C2, 1, if you will. So you're going to have to move to A2, because remember, scroll back up. If you start your I, and if your I sub index is 2, you're going to have to move to A2. So now I got to move to this one right here. A2. I don't know why I did that. Am I clicking a button? Maybe I am. I didn't think I was, but apparently, let's take a look. So A2, there you go. I stopped doing that. So A2, that's what I'm going to need. And then the rows are going to be the same. All right, so we'll do that one last one, and then I'm going to show you how to do it without having to write every single product, or the way I prefer to do it. So C21, you're going to do A2 times B1. So B1 is here. So 0, -2. So 0 times 2, 0. And then plus -3 times, sorry, -2 times 3. Which is the same thing I was going to say, but I flipped the factors anyways already. So 0 minus 6 is -6 for the next. And imagine if I have to write every single operation, that would take a little bit of time. So how do I do it? I'm going to erase all this and I'm going to come back. So let me show you how I do A times B. So this is how I do it. I think it's a lot easier. Whoa, I got a little excited there. I guess I prefer my method than just following the formula, huh? Got so excited about it. So what I do is the following. I grab the row. So I'm going to be doing the first row for my matrix. I know I'm going to have 3 columns because the second matrix has 3 columns. So I'm going to copy 1. I copy the row 1 and -3 for each entry, for each column. And I'm going to leave a little bit of space. If you notice, I'm not putting them next to each other because I need to fill stuff in. So I'm going to then copy the second row. I'm just going to copy it, 2, 3. And then you're going to get comfortable. You don't even have to do this. It becomes faster. But as you start, this is a good option. Then I'm going to copy my third row 3 times. You're not going to save a lot of writing, but you will soon enough, but not when you're starting. Okay? Soon enough. Do a few like this. After you've done 2 or 3, that's enough. You'll learn how to do it without it. So now, what I'm going to do for my first column, I'm going to grab this column and I'm going to transpose it and put it together with this. And I'm going to grab the 1 and the 0. I'm going to multiply the 1 times the 0. And I'm going to add the 3, but there's a negative, so I'm going to leave it as negative. So it would be plus -3, really, times, and I'm going to put my -2. So I'm going to be filling in with 0 and -2 right by my 2 numbers. And then the results I get, I add them, because when you do a dot product, you're just adding them. So I'm just encoding the dot product, really, but in a much, much faster way of doing it, because I don't have to be writing Cij, C1 something. So I did my first column. I put 0, -2, because that's what I had. Now I want to move to my next column, 1, 0. So I'm going to be putting 1, 0, 1, 0. And whenever there's not a sign, if there's not a minus, I'm going to put a plus. So times 1 plus 0 times 0. And then I'm going to grab my last. So in this case, I did this one. Now I'm going to do this one. So my last column, 2, 2. So I'm going to multiply everything times 2. This one is already subtracted. I could put plus minus, but it's not needed. Then 2 plus then 2. And then 2, 2. 2, 2. No, I'm kidding. And then I get my matrix now. I just have to operate. So the first one, remember, we had gotten +6. That's that. And we got the same number, thankfully. It'd be kind of embarrassing if we don't. Don't tell me if I didn't, because I won't go watch the video again. It's too late today. 1 times 2 is 2, minus 3 times 2 is -6, so -4. I remember that's what we got. And then the next one is for the next row, 2 times 0, and then 3 times -2. 2 times 0 is 0. 3 times -2, -6. I do remember we got that. 2 times 1, 2, plus 3 times 0, just 2. 2 times 2, 4, plus 2 times 3. That's going to be, what, 10? Yes. 0 times 0 times, so 0. 2 times -1, or -2 times 1, plus 0, so -2. And then -2 times 2, -4, plus 0, -4. Now, that is really, I'm lying to you, because that's not how I do it. But this is a good way to do it. So let's do another one, and I'm going to show you how I actually do it. After the 5th time, maybe I will show you the way I actually do it. The problem with this one is I need to do a hand motion, and you're not going to see it. because I'm doing this online. So, but anyways, I don't know if my hand motion helps anyone understand this. So B times A, and now B is a 3. So let me write it here because it's gonna get messy, more messy. B times A. B, remember, is a, I said 3 is 2 by 3. It was gonna be messy because I'm gonna say it wrong. A is a 3 by 2. So now the 3's do match, and the 2's are gonna give me the size. So AB is a 3 by 3. BA is a 2 by 2. Ah, that already tells us that the matrix AB is not the same as the matrix BA, and that automatically tells you that matrix multiplication is not commutative. You already have an example. I mean, it's actually hard to find examples of matrices that do commute. It's a much easier, but it's not hard. It's harder probabilistically. It's really easy to do, anyways. Whatever. I get this. I'm getting distracted from the fact that multiplication is not commutative. That's what I wanted to say. Then I got to talking. All right, so how do I really do it? Well, firstly, I should write the matrices backwards because if not, you may get confused. So it's not a good idea not to write them again. Once you get more experience, you can multiply them backwards without having to rewrite them. It's again not advisable at first. You have to practice. You have to pay your dues before you can start skipping steps or thinking that you can do it in your head. Not a good idea at first. So what I really do is I grab this guy. Whoa, I don't know what I do then. I grab this guy and multiply it on this guy, and that's gonna give me the first entry. By multiplying, I mean a dot product. I do the transpose already. So I do 0 times 1, and then 2 times 1, and then 2 times -2, and I add them. So I get 1 times 0, 0, 2 times 1, 2, and then 2 times -2, -4. 0 plus 2 plus -4 is -2. So I just put that here. Now when I want to get my next entry, I grab these numbers and I multiply it times this. So 1 times -2 is -2. 2 times 0 is 0. I have -2. So I just continue to add as I go. So I had a -2, and then -2 times 2 is -4. -2 and -4 is -6. And so it's the same thing. I'm still doing a dot product. This is the dot product written out. It's still the same. It's just, I think the way you do it, it kind of makes it a little bit easier. So for example, this right here, I'm going to multiply times the top. I get -3 times 0, 0. 3 times 1, 3. 2 times 0, 0. So 0 plus 3 plus 0 is just 3. And then you multiply again. So -3 times -2 is 6, plus 0 plus 0 is 6. Now, I will give you the answers for A transpose B transpose, because there's a little trick I'm using, but you're gonna think I'm a genius or that I edited the video, but I didn't. It's not. I promise it's nothing exciting. As soon as you see the answer, you'll know, but I do ask that you pause right now and multiply those transposes to confirm. So pause the video, do not look ahead, and then we'll talk about why. So here comes the big reveal of my secret. No, it's not a secret, and it's not a big reveal. Oh well, how disappointing. Is that whenever you have a product of matrices and you do the transpose changes order or satisfies what some people call the shoes and socks principle, which I'm going to describe whenever we do inverses for matrices in class. And no, it doesn't involve of me taking off my shoes, but I will talk about that. Mainly, I don't take off my shoes because I have holes in my socks, and it's kind of not great when you're teaching to do that. Anyways, so let's keep going with another example. So let's do a times b and then b times a. In this particular case, a and b are 2 by 2s, so every possible product will be defined because, well, it's always going to match, right? So 2 by 2, 2 by 2, the transposes are 2 by 2s. So if they're square matrices, you can multiply them in whichever order that you prefer because you can do the multiplications. There will be times when the multiplications will not be defined. Now, the fact that you can multiply them in whichever order that you want doesn't mean that you should. It means it depends what you're trying to accomplish. In this case, in this exercise, we're just trying to multiply to practice. So yes, we're going to multiply them in every possible way. So I'm going to multiply 1, I'm going to explain it again, and then so you can fast forward the video if you already understand it. In fact, pause now, compute AB and then A times B and then B times A, and then you fast forward. So I'm going to go ahead and do one more explanation just in case anyone's still having issues, and then hopefully we can all multiply B times A separately and reconvene after that. So I'm going to write them out, A times B. So I'm going to have 1 and 1. I'm going to be multiplying it times. So again, I grab my first column on the second one. That's going to be multiplied times the first and second rows. So let's do a circle here. So whenever I multiply the vector 1, 1, and whenever I say multiply, I'm talking about the dot product here, so we are clear about that. So when I do my 1, 1 multiplying negative 4, 6, that's going to give me, since I'm grabbing the first row and the first column, is going to give me the 1, 1 entry. So that's going to be 1, 1 times negative 4, 6 is going to be 1 times negative 4 is negative 4, plus 1 times 6, 6. Negative 4 plus 6 is 2. So it's going to give me that. That's the 1, 1. Now, when I move to the second row, so the second row is going to give me the second entry, or the second row on the result, and the first column of the second matrix will give me that is going to be in the first column of the result. So I'm going to have 1 times 1 is 1, plus 1 times negative 1, so 1 minus 1 is 0, so that's going to be my entry here. So I move to the next one, so I'm going to be having this 0, 1. I want to multiply that dot product again times the first row. So I'm going to do 0 times negative 4 is 0, plus 6 times 1 is 6. Where does that go? Well, it's in the first row, because it's in the first, I'm grabbing the first row of the first matrix, and the second column, because I'm grabbing the second column of the second. So first row, second column is right here. And that's going to be then, what did you say? 6. Yeah, I was already forgetting. I had to multiply it again, let's be honest. And now the next entry is going to be, I have the second row and second column. So it goes in the second row, second column. Again, the row in the first, the number of row in the first is going to give you the number of row in the result. Number of column in the second gives you the number of column in the result. So now you're going to do the dot product. So 0 times 1, 0, plus 1 times negative 1. So it's negative 1. So I'm going to multiply the other ones, and I'm going to rejoin you here in a minute. I'm not going to do transpose because now you know the tricks. It's just a matter of throwing transposes around and doing the right one. But I'm going to multiply the other one and we'll reconvene. So please pause the video, try to multiply, and see if we have the same result. Okay, so that's what I get for that one. Hopefully we'll get the same result. All right, so let's take a look at what else we're going to do today. I do an extra product. I think given that we're doing it in video form, I normally would assign this one already to you to solve, but there's a very important aspect here that when you multiply A times B, you can check this. This B is a special matrix. You may call it your identity matrix. And you know, some of us really need an identity, so this one will be today. So you grab this one right here and you multiply, and what's gonna do is you're gonna multiply it, and you can check, you get the exact same value back, the exact same matrix rather. So what when you're multiplying numbers, what do you know that you can multiply times any number and get the same number back? Is 1. So B is playing the role of 1, and this is going to be called the identity matrix. So whenever you think about matrix multiplication, and this extends to all sorts of mathematical objects and spaces, this is just one version of the identity. And so if for example you're multiplying times a 4 by 4 matrix, then your identity looks like this. But the common theme is that it has ones along all the diagonal entries and zeros elsewhere, and then you can verify that that would give you, whenever you multiply any n by 4 matrix times this one right here, then the result will be an n by 4 matrix that is going to be the same matrix that you started with. The same here, if you have a matrix that is m by 3 and you multiply that matrix times the identity 3, then that's going to give you the original matrix back. Now, you can multiply the identity not only on the right, you can multiply it on the left, but then you have to play the game differently, because at that point, you'd have to have that if you're going to multiply the identity on the left, then you would have to have a matrix that is 3 by k, for example, to be able to multiply times this one, and 4 by l to multiply times that one. But nonetheless, let's just say that usually we're just going to call the identity I, and the size is assumed to be such that you can actually multiply things. If the size is needed, then we're going to call it I sub 2, I sub 3, I sub 4. We're not going to do I sub 1, that we'll just call 1. All right, I noticed that this video was getting a little bit long, so I'm going to stop this video here, and I'm going to create another one where we're going to talk about the identity and how it helps us with inverses, or how it connects rather to inverses. So we're going to talk about inverses of matrices, but we're going to talk about them only for the 2 by 2 case at the moment. We need more tools to talk about them for larger matrices. So we'll stop right here for this one, take a breather, we'll reconvene for the next video. So thank you for watching all the way to the end.